All right, so got some more multiple choice question here. Um, Moon Company sells its product for $6 a unit. Fixed expenses are expected to be 200,000. Variable expenses are $4 per unit. That gives us a contribution margin of 2. How many units must they sell to generate income of 40,000? So that's 240,000 divided by 2 is 120,000, which is D. Last year, Flynn Company reported a profit of 70,000 when sales totaled 520,000. The contribution margin ratio was 40%. So 520,000 times 40% would be 208,000. They reported 70,000 of profit. So if we subtract the profit, that will give us 138 was in fixed costs. If fixed expenses increased by 10,000 a year, so now we're going to go to 148. What will sales have to be to earn a profit of 80,000? And that will be divided by our contribution margin of 40% or 0.4. 148 plus 80. 0.4 divide is 570,000 will be our sales for B. Okay, so now we've got one with use the following information to answer questions 3 through 5. The company's break even in unit sales is closest to, okay, so we need our fixed manufacturing expense, 486, fixed selling and administrative, 274. Any other fixed? No other fixed. So that's our fixed costs. Then we've got sales of 2,106 minus our variable costs of 975. And variable selling and administrative of 260. That will give us a total contribution margin of 871. Now, if we divide that by the 260,000 units sold, that will be $3.35 per unit. So if we divide this by 335, so 486 plus 274 and divided by 3.35 will be 226,666. 8. Missed it. So right there. The company's contribution margin ratio is, so that will be the contribution margin. There. The contribution margin is 871. The sales is 2,106. And that will be 0.4135. 0.414. And then finally, the company's degree of operating leverage. So we take our we take our contribution margin of 871 and divide it by the net income of 111. Is 7.84, 7.85. There. Okay, number 6. Whoops. Oh, there's that one, the 871 divided by the 111, which is the net income. That's the contribution margin. Gave us the 784, closest to 785. Okay, number 6. During the month of April, Vane Company produced and sold 10,000 units of a product. Manufacturing and selling costs during the month of April are as follows. Direct materials and direct labor, those are prime costs. 400,000 variable manufacturing overhead, fixed manufacturing overhead, and variable selling cost of 10. Assume that direct labor is a variable cost. Unit product cost under variable costing was. Okay, so direct materials and direct labor is 400,000. We don't have fixed manufacturing overhead under variable product cost, but we do have variable manufacturing overhead of 90. And variable selling costs are not a product cost, right? They are a variable cost, which we would have to figure if we're calculating contribution margin, but they're not a product cost. So we've got a total of 490,000 in variable product cost divided by 10,000 units, and that would be $49. Okay, next one's kind of long for multiple choice, but here we go. Manufacturing company has provided the following data concerning most recent month of operations. Selling price is $89, no beginning inventory. 4,300 units produced, 4,000 sold, ending units in inventory 300. That makes sense, right? Variable cost per unit, and then fixed cost. The total contribution margin for the month under the variable costing approach. Okay, so we've got 89 minus 13 and 35 is 48. 49.59. That would be $30 per unit. Units produced. Units sold times 4,000. Would be 120,000. Now we're back into some problems. The following budgeted data. We've got three products here. Budgeted net operating income for the month is 130,000. Calculate the break-even sales for the month. Okay, so what we do on this one is we take the total contribution margin. 160 plus 60 is 220, plus 160 is 380. total contribution margin, total sales, 800 plus 200 is 1 million plus 400 is 1,400,000. We get 380,000 divided by 1,400,000. And that would be a 0.2714 contribution margin, the break-even sales for the month. So we have the contribution margin. The operating income is just that minus that. So that would be 250,000 in fixed costs. So 250,000 divided by 0.2714 will be 921,053 rounded up. That calculate the margin of safety. For the month. So our margin of safety is 1,400,000 minus 921,053 would be 478,947. Calculate the operating leverage for both the budgeted and actual data. So we can do the budgeted first. Our operating, let's see, our contribution margin on that was 380,000 divided by 130,000. Will be 2.92. We'll have to get to the actual data here. So we have the actual total sales for the month was the same as budget sales. However, the sales mix changed so that sales by product L calculate the expected net operating income with the new sales mix. Okay. So we have to redo this. So sales is going to be 560 for L. Z would be 280 and C was 560. So we take the contribution margin ratio 160 divided by 400 is 40%. So we get a contribution margin here of 224. Let's see. Here we have 60,000 divided by 200,000. So our contribution margin ratio here was 30%. So here we're going to have 84,000. And then here we've got 160,000 divided by 800,000 is 20%. Is 112,000. So we have a total of 420 contribution margin, minus our fixed cost of 250, which was calculated earlier. And so we get 170,000 net income as opposed to 130,000. Explain why this is because we sold more, even though the total sales was the same, we sold more of product L, which has a higher contribution margin, and less of product C, which has the lower contribution margin. So there you go. Number 14. The following monthly data in contribution format is available for MN Company and its only product SD. The company produced and sold 300 units during the month and had no beginning or ending inventories. Without resorting to calculations, what is the total contribution margin at the break even? Well, the total contribution margin at break even is the fixed expenses, or 40,000. Right. B. Management is contemplating the use of plastic gearing rather than metal gearing in product SD. This change would reduce variable expenses by 18 per unit. The company sales manager predicts this would reduce overall quality of the product and would result in a decline in sales to a level of 250 a month. Should we make this change? Okay, so our contribution margin goes from 279 minus 91 will be 8. We had 18, so 188 would be the new contribution margin. Our old contribution margin was 51,000 times 250 units. Is $47,000. So no, we would lose 4,000. Our contribution margin drops by 4,000, so our net operating income also drops by 4,000. Assume that MN Company is currently selling 300 units of product SD per month. Management wants to increase sales and thinks this can be done by cutting the selling price by $22 per unit and increasing the advertising budget by $20,000 per month. Management believes these actions will increase unit sales by 50%. Should these changes be made? Okay, so go back to our original data. We've got 279. We cut the selling price by 22. We've now got 257. We've got the same 109. So our contribution margin now is 148 as opposed to 170. So we're going to have the fixed cost of 40,000 plus the 20,000 advertising expense divided by 148. $60,000. We need 405 to break even. If we did, let's see, 188 divided by 279 gives us a 67% contribution margin ratio times 450. Oops. 450. Way down. No. 279. 188 contribution margin ratio, contribution margin divided by 279 gives us 67.73 contribution margin ratio. Okay, so if we no, it's 148. Scratch all that. Okay, so we still have so it's going to work out. We should. Let's see now. So let me go over here and do 279 times 450 units is 125,550, and our contributions, our variable costs are the same. I keep screwing this up. I apologize for that. It's 257 is the new sales price. 257 times 450 units. Okay, so now we got 115,650. Now we're right. Now it's 109 times 450. Whoops. And so we've got something weird. 109. So we've got 49,050. There we go. 006. 66,600 minus 60,000, because we were at 40,000, but now we've added 20,000, so we would be at 6,600. So now we would be worse off by cutting the selling price and increasing our sales by 50%. And then D, assume that, so we should not do that. Assume that MN Company is currently selling 300 units and they want to automate a portion of the production process. The new equipment would reduce labor costs by $20 per unit, but would result in a monthly rental cost for new robotic equipment of $10,000. Management feels the new equipment will increase the reliability. The product has the increasing monthly sales by 12%. Okay, so we're going to have 300 times 1.12. So we would now sell 336 units times 279. So our new sales would be 93,744. So far looking good. We would have variable cost of 336 times 89. We cut the direct labor by $20. And that would be 29,904, which would be 63,840 is our contribution margin, minus our fixed cost would now go to 50,000, and we would make 13,840. So yeah, we would be 2,840 better off to automate. And there's the calculations down there. So our sales go up by 12%, so we go from 300 to 336. Our selling price stays the same. Variable cost 336, but our costs lower from 109 to 89. That gives us 63,840 contribution margin. We add 10 to the 40,000 fixed costs, and we end up with 13,840. That's good. Okay, some more multiple choice. A disadvantage of the high-low method is that it uses two extreme data points, which may or may not, which is why I told you, you always want to graph it to see if they're pretty much representative points. Which would be the most helpful in identifying outliers? That's a scatter graph for that. Number 14. Pedruska produces a product that is very machine intensive. They have determined that machine hours are likely explanation for manufacturing overhead costs. Therefore, machine hours are independent and variable manufacturing overhead is the dependent variable. The results of their regression analysis is as follows. The intercept is 22,500. The slope is X variable is 9.4. They're planning on an operating level of 15,000 machine hours. What is the formula for the equation? Total cost, same thing as we were using Y. So the total cost, or Y, is going to be the 22,500 intercept plus 9.4x. So that's our formula. Based on the cost equation, what is the estimated overhead could expect for the coming year is 15,000. So it's 22,500 plus 15,000 times 940. Is 141. Add those together. We get 163,500 for that. And what does the R square indicate? It's 0.952. So that tells us that this formula that we calculated here will predict 95.2% of the costs. Okay, which of the following is example of a fixed cost? That would be the straight line depreciation on the equipment. And then cost volume profit analysis is a key factor in many decisions, including choice of product line, pricing products, marketing strategy, and use of productive facilities. A calculation of CVP, cost volume profit analysis, is the break-even point. Once the break-even point has been reached, operating income will increase by the contribution margin per unit for each unit sold. Okay. Number 6. In the cost equation, total cost equals fixed cost plus Vx. The slope is represented by which of the following? It is the V. a comprehensive or overall formal plan for a business that includes specific plan for sales. That's budget. We don't do any of the budget, so you can skip that and that. That'll be the next test. I didn't get it edited out. I think it's the next one. It might be the third test in this book. Don't need those. Okay, so we've got the Javaris Corporation manufactures and sells T-shirts imprinted with college names and slogans. Last year, the shirts sold for $7.50 each. The variable cost to manufacture them was $2.20 each. The company needed to sell 20,000 shirts to break even. Net income last year was $540. Gewert's expectations for the coming year include the following. The sales price of the T-shirt will be $9. The variable cost will increase by 1/3. Fixed costs will increase by 10%. And the income tax rate of 40% will be unchanged. If Gewert's Corporation wishes to earn $222,500 in net income in the year, the company's sales volume must be. All right, so what we don't have right now that we need, and we can figure it out, is we need what the fixed costs are, right? So we know we're going to have $9 in the selling price, and we're going to have $2.25 increased by 1/3, so 1.333. And so essentially it'll be $3 per shirt, $2.90, keep going. And so that's going to give us $6 of contribution margin per shirt. So now we know in our formula, we know the 22, or desired profit of 22,500 divided by 1 minus 0.4, the tax rate. So we've got that. We know the $6 contribution margin. All we're lacking now is the fixed costs. Okay, so they needed 20,000 shirts to break even last year. So they had 750 minus 225 would be 525 was the contribution margin. And they had 20,000 divided by 525. Oops. So they had 3,810 of fixed costs. I just rounded that up, 3809.52, 3810. So we know that's going to increase by 10%. Is 4,191. All right. So 22,500 divided by 0.6 is 37,500. So 4191 plus 37,500 divided by 6 Okay. And divide that by 6. And we need to sell 6,949 t-shirts. Oh, sales dollars. So we can just multiply that times 9. $62,536. Something didn't work out there. I'm pretty sure I did that correctly. Oh, no, the fixed cost is what I got wrong. So 20,000 should be times. 20,000 times 525 is 105,000. Okay, so now we've got 105,000 plus 37,500 divided by, let's see, 6 divided by 9 is 0.666. $213,771. Yeah, so it'll be 213. There we go. On that one. Probably won't see one that tough. How would an increase in fixed manufacturing costs and variable selling costs, respectively, affect contribution margin? So fixed manufacturing, how would an increase affect the contribution margin? It wouldn't. An increase in variable costs would decrease. So no effect in decrease there. The disadvantage of the high-low method, we already did that one, which is the independent variable. That's V, a little different version of what we did earlier. At the break-even point of 14,000 units, variable costs are 84,000 and fixed costs are 42,000. What would be the operating income if all right, so break even, our contribution margin would be 42,000 minus 42,000 gives us 0 operating income. We know that this is 84,000. And so this 42,000 divided by 1,400 units is $30 per unit, so it would be $30. The Henley Haunted House wants to predict total cost as a function of the number of visitors. They will ultimately use the following information in pricing. The results show the following information. Using the high-low method, determine the cost formula and what would you predict costs to be for. Okay, so our high number of visitors is 300,000. Our low number of visitors is 150,000. So a difference in visitors of 150,000. Our costs are 3,070,000 and 2,785,000. $285,000, 285 divided by 150 is $1.90. Plug that back in there. 3,070 minus $1.90 times 300,000 equals $570,000. $2,500,000. If there were 275,000 visitors, we would expect 2,500,000 in fixed costs plus $1.90 times 275,000 and $3,022,500. Your answer there. High-low method. Okay. So we've got a product that we manufacture for 400,000. I think we did this one before, but we'll go ahead and do it. Yeah, we did this one before. So A is a NOLA. We've got 750,000 in fixed costs, 500 and 250. We've got 280, 300, 350, 180, 200, 250 in fixed costs. So we need 3,000 units to break even. So now we want B, 300,000, so 750,000 plus 300,000 divided by 250. We need 4,200 to make 300,000 pre-tax profit, and C, after tax, we've got 750,000 plus 90,000 divided by 1 minus 0.4, all divided by 250. So 900,000 divided by 250 is 3,600. I think some of the numbers might be different on that one, but the basic problem's the same. And then a blank sheet. All right, so that's it for that one. Yeah.